Subject Hydrology, chapter Hydrograph analysis, topic method of superposition. So now students, we have discussed about the assumptions of hydrograph, assumptions of unit hydrograph. We also discussed about what is unit hydrograph, what is a flood hydrograph, what is a direct runoff hydrograph, right? And what is an effective rainfall hydrograph, and what is excess rainfall or effective rainfall. All these things we have discussed. Now I am starting a new topic, method of superposition, but you will understand this topic, method of superposition, if and only if your previous lectures are cleared. That is the assumptions of hydrograph, assumptions of unit hydrograph, right? ERH, effective rainfall hydrograph, flood hydrograph, direct rainfall hydrograph. So if these concepts are clear, then only your method of superposition will be clear. So I hope that you have cleared all the concepts whatever I have taught you till now. Now let's go to the method of superposition. Now previously also I gave a hint about the method of superposition, right? For example, in a structural analysis, if it is a very complex structure, what we do, we break the structure into simple parts or simple structures, and then we combine the bending moment diagram, or we also combine the, you can say, the bending moment diagram, the shear force diagram, and so on. We get the answer, if you remember. Clear? Now same goes with the this also, right? Same goes with this also, right? So method of superposition. Now the question is, why it is even required? The method of superposition, why is it even required? So let me give you an example. Let us say that for a particular catchment area, this is a particular catchment area, okay? Now you have been given, for this particular catchment area, you have been given a, you can say, now let us say for a particular catchment area, you have been given a unit hydrograph, right? So this is a unit hydrograph for a particular catchment area, right? How you have got the hydrograph? Now from at the catchment, you can say outlet, you have made a you can say gauging station, and with the help of this gauging station you recorded the, you can say, the effective rainfall, you recorded the, you can say, the runoff, and hence you have got the hydrograph, unit hydrograph, right? So this is the unit hydrograph that you have got. Let us say this unit hydrograph, it was of d hours duration. Now don't get confused in d hours. Let me take 4 hours. Don't get confused, right? You have taken a unit hydrograph 4 hours duration, and unit hydrograph means it has a depth of 1 centimeter, and let us say it has a peak discharge of 20 meter cube per second for the time being. 20 meter cube per second. This is what we have got. Okay? Now, but this is a 4-hour storm, or you can say 4-hour unit hydrograph for a particular storm which has lasted for 4 hours. But is it, you can say, is it always true that even, let us say that this data you recorded in November 2014. Let us say November 2014, you recorded this data. So what do you think? Even in December 2014 also, you will get the 4-hour storm? Even in July 2015 also you get the same storm? In January 2020 also will you get the only 4-hour storm? No, this is not possible, right? That is, you can say, very less probability that every year you are just getting a 4-hour storm. You can also get a 5-hour storm, you can get a 6-hour storm, 7-hour storm, 8-hour storm, and so on. But you have a unit hydrograph of just a 4-hour storm only. Then what you will do, right? Now, is it, you can say, is it really economical to get the data every year? Now what is what will be the use of this unit hydrograph? No use. So there should be a use of unit hydrograph, right? So just with the, for example, in November 2014 you recorded this unit hydrograph. Clear? Now with the help of this unit hydrograph only, you can say extrapolate the data for a 5-hour unit hydrograph, for a 6-hour, 7-hour, 8-hour, and so on. So no need to, you can say, there is no need to again and again record the data at this gauging station. So what we do for this, we have two methods. The first method is method of superposition, which we are going to study just now. So method of superposition. Method of superposition. And the second method is the S-curve method. S-curve method. Clear? Now, method of superposition in the simplest terms. Now, let me explain the method of superposition. For example, you know that function of 2 is equals to, let us say, 4. Clear? You know that function of 2 is equals to 4. If someone says you that what will be the function of 4, you can say not like this. Let me tell you like this. Let me rub this to make it more simpler. Let me say that you know that 2 plus 2 is equals to 4. 2 plus 2 is equals to 4. If someone says you what is 4 plus 4, obviously it will be equal to 8, but you know only this thing. You know only this thing. You are a small kid. You know 2 plus 2 is equals to 4. You don't know 4 plus 2, 4 is equals to 8. So what you will do, if you are a little bit intelligent, what you will do? Okay, so this is 2. So I can write 2 plus 2. This is 4 plus 2 plus 2. Now 2 plus 2 is 4 and 2 plus 2 is 4. Clear? So this is the method of superposition. Now what we are doing is that we are using the fourth assumption in this, that is the linear response. So this is the method of superposition. Simple, in the most layman term I can say, right? This is the method of superposition. So for example, if you know 2 plus 2, then you somebody asking you what is 4 plus 4, but you don't know what is 4 plus 4, what you will do? Just 2 plus 2 and 2 plus 2. This is 2, 4 and this is 2, 4. So you will get 8 is the correct answer. That is how this is a you can say superposition. Now this was a layman term, right? But we are engineers, we are civil engineers. So now let us understand this method of superposition with the help of hydrograph, right? So let me first of all rub this, right? So let me rub this. Clear? Now let me give you this example only. Let me give you this example. Let me not rub this hydrograph. Let me give you this example only, right? And why are they used? The method of superposition. When are they used? I will be explaining you, right? Okay. Now, first of all, let me tell you when to use method of superposition and when to use S-curve, right? So first of all, I will give you a bookish definition, when to use it, when not to use, right? Use it, right? And then I will be explaining you why I cannot use method of superposition in a particular case, right? So first is the method of superposition, right? So first is method of superposition. Method of superposition. So write it like this. It is used when MD, our unit hydrograph, is to be found out from D, our unit hydrograph. D, our unit hydrograph, where M is a positive integer. M is a positive integer. M is a positive integer. It means that, for example, you are given a 4-hour unit hydrograph. Let me take this example only so that you don't get confused. Let me take this example only. This was the y-axis, right? This was the y-axis. On y-axis we had discharge, right? On the x-axis we had time, right? This is a 4-hour unit hydrograph like this. Let us say it is like this, right? So this is a 4-hour unit hydrograph. 1 centimeter is the depth of rainfall, effective rainfall. This is 20 meter cube per second. Let me take this example only. Don't get confused, right? Now this is a 4-hour unit hydrograph. If you need to determine a unit hydrograph for 8 hours, or for, you can say, for 12 hours or 16 hours or 20 hours, then the method of superposition is valid. For example, you need to determine, let us say, unit hydrograph for 8 hours. So what is 8? 8 is a multiple of 4. 4 into 2, 8, right? 4 into 3, 12. 4 into 4 is 16. So if M is an integer, it is a positive integer, then the method of superposition can be applied. Now, how to apply the method of superposition? Now, this is a 4-hour unit hydrograph, but in question it has been given to you that you have to calculate the 8-hour unit hydrograph. It means the storm has lasted for 8 hours, but you only have data for 4 hours. Then what will you do? You will use the fourth assumption. Then we will use the fourth assumption as well as the third assumption. So what is the fourth assumption? Fourth assumption is about the linear response, and the third assumption is about the time invariance, right? So when you apply the third assumption, for example, this is a 4-hour unit hydrograph is given to you and you need to calculate a 8-hour unit hydrograph. So from the fourth assumption, can I write that an 8-hour unit hydrograph will be equal to 4-hour unit hydrograph plus 4-hour unit hydrograph? From the fourth assumption, the linear response, right? Now coming to the time invariance, whether it starts at 8 a.m. or whether it starts at 8 p.m., the shape will be same. Clear? Now, can I write it like this? Let us say I want to draw a 8-hour unit hydrograph. This is discharge versus time, right? So the 8-hour, right? So first one is first for 4 hours. This is for 4 hours, 1 centimeter. Now again, if I want to calculate a 8-hour unit hydrograph, can I write 4 plus 4, right? So 4 and plus 4. So 4 plus 4. This is also 4 hours. This is 1 centimeter unit hydrograph and 1 centimeter, right? Now the 4-hour unit hydrograph, it started from the origin and the shape of the hydrograph was like this, right? Now this is the 4-hour unit hydrograph again. Now it has started after 4 hours, it has started, right? So you will give a lag of 4 hours. This is your 4 hours. 4 hours, and you will start the hydrograph from here, and the shape of the hydrograph will be same, the base period, everything will be same due to the third assumption, that is time invariance. And what is the fourth assumption? The linear response. So this is known as the superposition method. But now, if you have superimposed this, right, if you add the ordinates, the resultant hydrograph will be like this. Now, let me draw the resultant hydrograph. So, the resultant hydrograph would be like this, This will be the resultant hydrograph. Clear? After some time, it will be same. It will start from the same base and end at the same base. So, this is the resultant hydrograph, right? So, I can say that if I draw this graph at here, so I can say that this is your discharge, this is your time, so this is the resultant hydrograph. Now if I write about it, what is the depth of rain, what is the duration of rainfall? So the duration of rainfall will be 8 hours. Duration of rainfall will be 8 hours, right? Why? Because 4 plus 4 is 8. I needed to calculate the 8 hours hydrograph. But this is a 8 hours direct run of hydrograph. This is not a unit hydrograph, because from the fourth assumption, linear response, if you are adding 1 centimeter plus 1 centimeter, this hydrograph will have an effective rainfall of 2 centimeter, not 1 centimeter. So you will have a depth of 2 centimeter. Now you have got a direct run of hydrograph. If you want to convert a direct run of hydrograph to a unit hydrograph, what you have to do? You have to divide it with the, you can say, effective rainfall. Simple. So if I divide the ordinates, now ordinates divided by 2 centimeter, I will get a unit hydrograph. So unit hydrograph will be like this. This is discharge, this is time, like this, right? So this is the 8 hours and the depth is 1 centimeter, because I have divided the ordinates with 2 centimeter. Clear? So that this I have already told you, that if you want to get a unit hydrograph from a direct run of hydrograph, what you have to do? You have to divide the ordinates with the effective rainfall. Clear? Or rainfall axis. Clear? So I hope that you have understood the method of superposition, how the method of superposition is applied. Clear? Now let's, in the next topic, now let us solve one numerical based on the method of superposition and further understand the concepts of method of superposition. Thank you.